This is the intro to section 4.2, part 1, where we're going to talk about triangle congruence by SAS and SSS. Now, objective here, we're going to prove that two triangles are congruent by using side, 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 which is SSS, and side, angle, side, which postulates, which is SAS. Okay. All right. Now, we talked in section 4.1 about how we can prove two triangles congruent using all their parts with the definition of congruent figures. Okay. But you can prove that two triangles are congruent without having to show all that, without having to show all the corresponding parts are congruent. Okay. In this lesson, we're going to prove triangles congruent by using two things. Now, in part 1, we're going to talk about 3 pairs of corresponding sides. Part 2 will be 2 pairs of corresponding sides and 1 pair of corresponding angles. Okay, so let's start out with postulate 4.1. Another way to prove triangles congruent is with postulate 4.1, and postulate 4.1 says if the 3 sides of one triangle are congruent to the 3 sides of another triangle, then the two triangles are congruent. So if you look at the picture here, what this is showing is that the corresponding sides, all of the corresponding sides are congruent to each other. So AB and DE are congruent to each other. They're corresponding sides. BC and EF are corresponding sides. They're congruent to each other. And AC and DF, those are corresponding sides, and they're congruent to each other. So if all 3 corresponding sides are congruent to each other, we can then say that the two triangles, in this case ABC and DEF, are congruent to each other. Okay? So now what you're going to do, instead of necessarily only having definition of congruent figures to prove a triangle is congruent, now you have definition of congruent figures and you have the side, side, side postulate. So you don't have to have absolutely everything to prove two triangles congruent. Okay, for example, let's take a look here at this proof. It says using side, side, side. In the given, we're given that LM and NP are congruent to each other and that LP and NM are congruent to each other. And they have those marked in the picture. Remember, if they don't have them marked in the picture, you need to mark them. It's much easier to see if you can mark them. So, as you look at the proof over there on the right, I've put those 2 in for our first statement. And we're going to add those in as our given. LM and NP are congruent, and LP and NM are congruent. Now, obviously there's no angles here that are marked or that have been labeled congruent. So we don't have enough information to mark any angles congruent, so we're not going to use definition of congruent figures. But as we look at this, you'll notice you see the diagonal line here that both, if you were to take these 2 and separate them, they would both have this line that they share, which is NL. So I know that in each triangle, NL is congruent to NL. And if NL is congruent to NL, I can put 3 markings here in my picture. What would the reason be for that? As you look at your tool belt, this is the reflexive property. Remember, we mirror on each side the exact same thing. Now, if you look at your picture now, okay, as you're looking at your picture, you'll notice that corresponding 1, corresponding 2, corresponding 3 sides that are congruent. So now I can show that triangle LMN is congruent to triangle NPL because of the side, side, side postulate. We've shown that all 3 corresponding sides in that triangle are congruent to each other. Okay, before I start this proof, I want you to hit pause and see if you can do this one on your own. Okay, it's similar to the other one as well, but see if you can do this one on your own and complete it, and then take a look at what I have written down for your answers and the steps, and see if you get it correct. Okay, now that you've paused your video and you've come up with your reasons here on the proof, I've put in the first statement, Okay, that's going to be our given. So let's write down here, that's our given. Okay, and again, as you look at the picture, you'll notice we already have two sides here that are congruent to each other. Two sides here, CD and FD, and FB and CB. Those two pairs of sides are congruent. We just need to show that the third one is congruent, and we can then say that the triangles are congruent using side, side, side. Well, as you look again, they share a side, so the side that they share, BD, is going to be congruent to itself, BD, in each triangle. Again, if you were to separate those out and draw them, you'd have a BD in each triangle. Then this is the reflexive property. And now I can put my markings in my picture. And now I can say now that the two triangles, BCD, is congruent to triangle BFD by the side, side, side postulate. Now, yes, the two proofs that I've shown you are using the reflexive property. Will it always be the reflexive property? No. But you're going to use the reflexive property quite a bit as you're looking through on these. Okay. So as you look at these problems, okay, as you look at these problems, I went through a couple proofs here. We've shown how to show side, side, side postulate. This concludes 4.2 part 1. Don't forget to complete your WSQ.